let's get this thing rolling. So my name is Anthony Khamly. I'm here, one of the VAG techs here at Opus. If you've talked to me before, you probably worked with me as far as the Volkswagen and Audis go. Today we're doing a webinar, mastering Volkswagen electric vehicles and Audi E-Tron. So in this webinar, you're getting an introduction to Volkswagen Audi electric vehicle technology. A little bit more on that as we go through, as we are slowly moving away from fossil fuels as far as manufacturers go. Volkswagen Audi has been very prominent in moving towards that. Obviously, the number one manufacturer that was out there that started the movement was Tesla. Doesn't mean that Volkswagen and Audi were not in the electric car game. It's just we are playing a little bit of catch up. Okay, so in this webinar here, we are going to be covering the Volkswagen Egolf, which is essentially Volkswagen's first true mass-produced electric car. And as far as mass-produced goes, it wasn't a car that was available everywhere. It was only available in large US cities, large US markets. So if you guys are coming from, the Los Angeles area, New York area, big cities, Orlando, Seattle, it was mostly these big cities that first got this car. Okay. The other thing that we're going to be talking about is the Volkswagen ID platform, which is essentially the platform that Volkswagen is moving forward on as far as all their electric cars, not Audi, but actual Volkswagen. No talks about any other vehicles at the moment, but everything is going to be, ID something. That's the way they're designating their Volkswagen electric cars. And then the other thing that we're going to be talking about is Volkswagen's MEB chassis, which is a modular electric drive. If you're not familiar with Volkswagen, they also have the MQB, which is essentially what you see on the new Golfs, Jettas, Passats. Well, Passat's going out now, but Volkswagen Golfs, Jettas, GTIs, they're all based on the same platform, which is on MQB, the firewall forward. MEB, which we will be talking about, is strictly for the Volkswagen electric car. The other thing we're going to be talking about on this and covering in this webinar is Volkswagen Audi battery technology. We're going to be talking about the batteries that they have used, the generation, and the direction that they will be going in, and also the plants that they have planned to come up with and the plans that they want to do for the future. Along with that, we're also going to be covering Audi E-Tron history and introduction. A lot of people get the E-Tron moniker a little bit confused, along with talking about the current and future Audi E-Tron platform. And then we're going to dive a little bit into the E-Tron drivetrain gearbox technology. I wish I could push every single thing about the E-Tron and the Volkswagen ID technology into this webinar, but we have an hour. What we're going to do is an introduction here. Maybe later on in the future, we'll get into a deeper dive into all the technology, the way the systems work, the wiring, the CAN bus, the diagnosis, and all that. So getting started, this thing right here, the Volkswagen E-Golf, I'm sure some of you guys have seen it. Some of you may never have seen it, but essentially it looks exactly like a regular Golf. The E-Golf first came out in 2013. It was Volkswagen's first mass-produced electric vehicle, and this was a pure electric motor. If you guys know, they did offer hybrid vehicles back in 2013, but this car itself was strictly electric. Okay, when this car first came out, the EPA estimate was about 83 miles at full range. At that time, the only other vehicles out there that were electric, we had the Nissan Leaf, the Toyota Prius, GM had they started introducing these electric cars out here. Volkswagen was kind of tiptoeing around this. This was after 2 years of research. along with introduction of the Audi A3, which we'll be talking a little bit later. They actually started that research back in 2011. So this is the first generation. In 2015, they came out with the second generation Egolf. That second generation Egolf, they actually got up to about 125 miles on a full charge. Great for getting around the city. You know, obviously first gen technology, they did have issues, but you know, as the time went on, they started improving on these issues. And this was all pretty much research into what they put into their newer ID4 vehicle that just came out, and their new ID platform-based electric vehicles. So the Egolf was first mass-produced. You know, it obviously, as a first mass-produced vehicle, it was actually based off the Golf platform. Okay, the car was assembled in the Wolfsburg assembly in the Wolfsburg plant in Germany. The high voltage components were installed in Brunswick in Germany, and then the electric motor and transmission were produced at Kassel. Okay, so this was all in-house, producing all of these components to put this car together before they brought it out. Volkswagen pride, their pride and joy was the fact that they produced this entire car all in-house, and there was no, you know, exterior hands touching it or other manufacturers, although we know control modules are built by Bosch and other components are built by different manufacturers. So if we look here, quick look at the Egolf, and this is essentially how the new electric cars were built. The ID platform is based similar on this, but the Egolf battery runs almost entire length of the vehicle on a modified Golf chassis. The bottom pan of the vehicle was cut and stretched and completely flattened so they could run this battery pack underneath the vehicle, which essentially, I'm not sure if anybody has seen one in person, but it's a pain. Okay, to work on these batteries, you have to drop that entire battery pack. They made this a little bit harder for anybody that did not have the equipment to work on it. You did need a the hydraulic table to drop this down. I mean, I've seen people do it on tires, which isn't exactly the best way to do it, but it's been done. The entire chassis of this vehicle, because of the battery placement, was reinforced. One thing about this, because the battery was so low, the aerodynamics of the vehicle was greatly improved. So Egolf, it ran a single speed transmission, just like pretty much all electric motors out there, electric vehicles. It's a single output ratio and is connected directly to the e-machine, which is what they call the electric motor for the Egolf. Okay. The e-machine, it basically is turned in reverse gear, reverse direction to get it in reverse gear. The engine, they designate it as a VX54, and I'm not sure if you've worked on enough Volkswagens or Audis, but they love their designations. So VX54 is strictly for the Egolf. It's a 3-phase current drive. They use this similar engine on their hybrid vehicles as well. This is before they strictly used it just for the Egolf itself. And like I said, this was strictly, you know, they mass produced this vehicle, but it was strictly a test vehicle for the, you know, the open market, to what they deemed is going to be their future in manufacturing. So the Egolf runs a single 3-phase engine. It produces 115.5 horsepower and 199 foot-pounds of torque. Having that low amount of horsepower and torque compared to other electric vehicles out there wasn't too bad, because that car was not that heavy. Okay, plenty of power, plenty of torque. essentially that car was built to putt around town. This was not meant to make it out on an open highway, although there are people that have taken these cars cross country. Obviously, you'd have to map your way across. It runs the standard electric charger. Okay, they also provide it with a 110 charger that you could take with you that took forever to charge. Also, the quick charger for these cars, they weren't exactly the fastest. A 30-minute charge on here would probably give you about 60 to 80%. A full charge on a high voltage charger would take about 6 hours, or excuse me, 4 hours. So Egolf electronic drive power and control electronics, they integrated all into one. Okay. If you guys have ever opened up an Egolf engine compartment, you'll notice three components there. One is the battery. They have a normal 12-volt battery, which you can see in the top right corner. The other is going to be obviously the largest part, which is the electric motor itself. And then third is that electric drive power and control electronics. This whole purpose for this component, it controls the current flow from the high voltage battery to the three-phase motor, but it also supplies a 12-volt battery voltage to the 12-volt system because it has the voltage converter built in. Other component that you'll also see there that's lying right on the top off to the side is the actual battery charger itself. Okay. In the engine compartment, the whole purpose of this is to convert alternating current to direct current to charge the high voltage battery. And it also supplies power to the AC compressor and the PTC heater. Okay. This unit itself is coolant cooled. Okay. It ran coolant through it. They have a separate pump that would run coolant through the electric motor and also the charger. If you look on the side, there is a typical Volkswagen coolant reservoir, which is where they would store the coolant, and then they would run it through to cool this down. There were a couple issues with these when they first came out. They did suffer from coolant leaks. If you get some of these that come into your shop, obviously you're going to want the correct equipment to work on them, but definitely take a look at the coolant side of it because it is a common leak for it. Egolf, just like all high voltage systems out there, will have orange cables, orange wires running throughout the system. That's an indication of the high voltage line running the entire length of the vehicle. Okay. So on these cars here, what you'll see, the compressor, the heater, the charger, the motor, and the power electronics are all underneath the hood on the front of the vehicle, versus the only thing that you'll see in the back that has a high voltage cable is going to be the charging socket and then the rear connections for the battery. Okay. So if you look, you'll see the orange wires running along the bottom of the battery. We'll get a little bit more into some of these batteries as we move on, because I'm going to actually bring up the battery technology that Volkswagen and Audi uses. So first things, this was an image that they had put out, I would say about 10 years ago. Volkswagen ID platform. This image here is based on what they thought would be the cars that would be taking over the future. All right. 10 years later, we have one of the cars in the picture and the second one, which is going to be coming out in a couple years. Now, that being said, if, type away on here if you guys know which car we actually have out there and if you recognize it. And then the second one, if you know which one's coming up next. So this is a video that they came up with just as a teaser for the cars. These were actually real life cars that they tested here. Everybody was like, hey, this looks like a rendering. This last image was not a rendering. It was actually a video that they shot in, I believe, Atlanta. So that being said, first things first, we're going to talk about the Volkswagen ID4. Yeah, past silver one out there, third one for the future. It's actually the red one and the yellow one. The red one, which is the ID4, and the yellow one, which is the Buzz. So first one that we're going to talk about, this is the current and only electric vehicle that you can get from Volkswagen, which is the ID4. Front and back, essentially it looks like a completely different SUV than what Volkswagen has out there in the market. Volkswagen also has the Tiguan, the Taos, and also the Atlas. Okay, those three SUVs out there, there are no plans to make them electric. The only ones that are going to be electric are these ID-based engines or ID-based vehicles. ID4 configuration, it comes in 7 different trims. Okay, and if you don't know Volkswagen and Audi, they love their trims. Okay, they come in a standard, the Pro, all-wheel drive Pro, the S, the Pro S Plus, all-wheel drive Pro S Plus. Essentially, none of that really matters. Those are all trim packages, seats, interior, electronics, exterior trim. That's what most of those are. The only ones that are different is that everything other than the ones that have an all-wheel drive designation are the same. So everything has a single motor, which is a rear-wheel drive, and then everything else that's all-wheel drive has a twin motor. The estimated base range for the rear-wheel drives, based on the 62 kilowatt battery, so this was the first year that came out in 2022, was 209 miles per charge and up to 275 miles on the 82 kilowatt models, which is now out. So they released the 82 kilowatt models late 2022 after the initial release of the ID4. So 275 miles is what they estimated at. We have seen cars come in, going in to get the charge, and they've put almost 300 miles. We've even heard of some people reaching 300 to 320 miles on a single charge. Okay. Obviously, you know, as they say, it's how heavy the foot is. Okay. If you got a lead foot, that battery voltage is going to go down. Okay. So power configuration for the ID4, you usually see 146 on a base model to 295, and that's with the boost on the engine. Torque will be at about 162 foot-pounds of torque and up to 340 foot-pounds of torque on the all-wheel drive twin motor, and obviously on full boost. Okay. Volkswagen acknowledges all-wheel drive models with tow packages. They actually have a tow hitch kit and tow package for it. They've done demonstrations and they say that these ID4s can tow with the best of them. I mean, with, you know, close to 340 foot-pounds of torque, I think you can tow around some small trailers and whatnot, but I wouldn't be taking that on anything big. Now, ID Buzz, this was the second car that Volkswagen is actually coming up with. Okay. The ID Buzz coming out in 2025. If you guys are familiar with this, it looks like the old bus because that is exactly what it is based on. All right. They did testing in California. They actually had this car out driving around. If you guys are in the Los Angeles area, they had it out in Venice driving around. They shot commercials for it. They did some fuel testing, some efficiency testing. So they drove it to test out the mileage. But this car right here, you know, they're not taking any pre-orders yet, but they will be soon. They said most likely next year, but it has been confirmed that this car will be out in 2025. All right. As of right now, it is confirmed to be a 5-seater. I believe it is going to be a possible 7-seater, depending on improvements that they're working on this car. So the one thing that the ID Buzz and the ID4 will have in common, along with every single ID Volkswagen out there, is that it's going to be using the MEB chassis, which is the modular electric drive. So essentially, I see that question that Chris Martino had asked here about the modular battery pack. The E-Golf was not a modular battery pack. It was specifically built for the E-Golf. It was for testing. Like I said, that vehicle was out for the testing market, but not for the ID platform. But the ID platform, according to Volkswagen, this entire setup should be interchangeable. So if you, let's say, had a 77 kilowatt battery versus an 82, you could swap that out in theory. You know, Volkswagen has left that kind of open as far as cars in the past. You know, coding can change things. People have done retrofits, so that's something that may be coming in the future for people that want to upgrade their battery packs. But every single one of these ID vehicles will be based on the same chassis, same platform. Okay, so MEB basically means the power electronics is the same, the charging plugs, charging outlets, the inductive charging panel, the batteries, the engine, so the entire drivetrain are identical from vehicle to vehicle to vehicle. So ID4 body structure on MEB, this is just a little cutaway of that ID4. They changed the chassis multiple times, but the interior space is a lot larger than it actually looks. If you've not seen an ID4 in person, I actually think it looks almost as big, if not bigger, than the Tiguan. I think it's a nice mix in between the actual Tiguan and the Atlas. This whole MEB floor plan is supposed to be a longer wheelbase that overhangs on the front and rear. And it's going to be slightly shorter in MQB. However, because of that, the battery is bolted to the vehicle right between the front and rear axles. So they want that to be located underneath the vehicle floor, provides a lower center of gravity, a more balanced weight distribution. So the car actually drives amazing. Interior space looks, you know, essentially exactly the same as any other car. A lot less things in there that, you know, have to do with, you know, like you don't have a shifter coming out because it's got a normal transmission. It's got a single speed, everything's electrically controlled. And then the electric drive motors are located directly on the axles. So there's a lot of space savings there. And also it keeps the center of gravity low to the ground. So we're gonna go over the high voltage system structure on these MEBs. Exactly this, like I said, these are exactly the same. You got the high voltage battery. It runs across the floor plan of the vehicle. The ZX17, the high voltage heater, is exactly the same spot for every single vehicle. So is the compressor and the PTC heater. So obviously this one right here is a rear wheel drive ID4. The all-wheel drive ID4, the AC compressor is slightly offset because you'll have a second engine there. Okay. High voltage battery charging socket located exactly at the same place. Power electronics, the charging unit itself, everything is all in the exact same space. And that's what makes the MEB chassis so good. So this right here is the actual high voltage battery. As you can see, there are 12 cells sitting in here, or 12 packs, okay, where the battery cells are. And you'll see all the cables internal. Now, previously on the Volkswagen E-Golf, you were not allowed to take that battery pack apart, although in the aftermarket world, as we know, we touch everything and anything. At the dealer, they were not allowed to do so. these battery packs were to be shipped back to their emission center, depending on where they were. If you're on the West Coast, the emission center is down in Westlake, California. I don't remember off in the Midwest, I believe is in Illinois, and on the East Coast, I believe they have one in North Carolina. Now, when it comes to these now, because of the technology that they've moved from upon studying the Egolf as it was out in the market and the common failures, these now are able to be taken apart and serviced individually. So before anything else, you know, the Egolfs, you couldn't service them, you had to take them apart, send them over to Volkswagen, they would take it and send it to their emissions lab. But now it can be serviced, okay? So high voltage battery on the ID4s, they're gonna be anywhere from 58 kilowatt to 77 kilowatt. I believe they are coming out with an 82 to an 88. The weight of these battery packs is anywhere from about 840 pounds to a little over 1,100 pounds. So these are not light. When you take these out to drop this battery, I got a chance to firsthand see these battery packs on the ground. A tranny jack will not suffice because you need this thing completely balanced. Unless you can get somebody to weld you a special jig for it that attaches to the tranny jack, you might be able to handle it that way. But you do not want to lower this in a weird manner because it can, as they say, warp the actual body that holds those batteries. Cell technology, it's a lithium ion prismatic pouch. It's a 400 volt nominal voltage for this battery. Number of modules 9 to 12. So the one that we see in the picture here is a 12 module, which is going to be the 77 kilowatt an hour. The 9 module is going to only be at 58 kilowatt. It is liquid cooled. Okay, so operation range is going to be anywhere from -18 to 104 degrees, and that's, you know, external temperature. Okay. The high voltage battery, lithium battery, is located underneath the vehicle underbody. You know, as we've talked about on, you know, pretty much most Volkswagens out there for electric vehicles and all these Audis, there will be, you know, they're all installed in the same area underneath the vehicle to optimize the weight distribution and to keep that center of gravity low. I don't know if any of you guys are, you know, motorsports guys, but we've been able to take the Egolf out on the track and surprisingly performs very well because of that low center of gravity. Okay. The electric energy for driving is offered for both 62 and 82 kilowatt. Only the 82 kilowatt batteries offered at launch, which now is standard for pretty much all of them. Chris asked here, are there special jacking points underneath this vehicle? There are. I don't know if you've on Volkswagens and Audis, most of these jacking points are, you'll see them marked on these as well. They will be marked underneath on the actual chassis of the vehicle, because if you notice on this battery pack here, you see all the holes on the outside exterior of that, what they call the chassis. That is where it bolts to the actual vehicle. So just like the Egolf, there are special jacking points, and then you can drop the battery packs. Next up, we're going to be talking about the 3-phase, the current drive with the 1-speed transmission. Okay. The ID4 runs this same engine right here with the single speed, and they run it on, and it will be running the same engine or the same motor on every single vehicle. Okay. Supposed to produce about 201 horsepower, 228 foot-pounds of torque, but that's per engine. The rear wheel drive. So obviously the twin engine is going to produce a lot more power and torque. These 3-phase engines will drive the vehicle and also charge the high voltage battery as an alternator, as we know. Now, the one thing to take a look at on here as well is when you take a look at this, the charging point will be exactly the same. They try not to make it look weird on other vehicles where they have, I mean, on the Audis, they have it on the front, on the ID4 and on pretty much most of the Volkswagen electric vehicles, they're in the rear, just like a normal gas lid would be. Okay, you would pop that open. That's where you would get to your charging port. Okay, so charging connector, J1772, it uses that same connector, so you can pretty much go to any charging station out there. Okay, it's a SAE standard, max charging capacity 7.2 kilowatt to 11 kilowatt. You use the quick charger, which also houses the DC connector. It's anywhere from 50 kilowatt to 125 kilowatt. The communication line, and I'm sure some of you guys will see this when you have an issue with the charging socket, or if you do not make a good enough contact, because obviously on here, it does a handshake when you first plug it in. And if the car doesn't see that handshake, car doesn't charge right, you may see some of these come into your shop. They have since fixed that, but you may see a couple of these pop out because these cars are, I mean, in the big market and the larger cities, we see these cars, everywhere. So right here, we're talking, this is going to be the high voltage charging unit. Okay. Input 78 volts to 272 volts, 60 amp to 50 amp. Output 220 to 470 volt. 2 phases on, it's a 2-phase charger you're on here. Max charging capacity 7.2 kilowatts, 11 kilowatt, 94% efficiency. This is what we're going to be seeing, on the towards the rear of the vehicle. Like I said, everything is installed on the rear of the vehicle, unless you have a twin engine, twin motor on here. This unit here, we have seen some issues. In a later webinar or class, we can get into this a little bit more, but we're just going to be kind of going over the components on this system. Charging unit converts alternating current from the charging connection to a direct current for the high voltage battery. Now, this right here, we are talking about the power electronics for electric drive. Okay, located directly on top, the component has an integrated capacitor, which is why a secondary voltage check is required to de-energize this high voltage system. I don't know if you've ever de-energized an Egolf, but it's very similar to de-energizing an Egolf. It goes through a series of checks that it needs to do before it will allow you to completely de-energize it. JX1, it's the power control and control electronics for the electric drive. It converts the customer's request as an electric and turns it into an electrical signal. The power electronics controls the 3-phase current drive. DC voltage from the high voltage battery is converted into 3-phase AC voltage for acceleration. Okay, so this is mainly for the vehicle move to control the drive. Now, another high voltage component on this is going to be in the front of the vehicle, is that high voltage compressor. Okay, it's a scroll style compressor. It runs anywhere from 195 to 470 volt. Functional engine speed 680, 600 RPMs. Refrigerant for the US, which I know everyone hates, R1234YF. Okay, runs R744 in Canada, but this right here also high voltage on the system. So be careful with this. The compressor is obviously integrated into the high voltage system because it's used to both cool the interior and the high voltage battery. Running here, this is the voltage converter. Okay, this will basically take care of the 12 volt system. So it's going to take your high voltage and drop it down to 12 volts and pre-charges the capacitor in the power electronics for the electric drive. This one is also coolant cooled. You notice a lot of coolant cooling in these vehicles. The Egolf was about a split 50-50. These newer ID cars are almost completely coolant or liquid cooled. This right here, PTC heater element, also located in the front. Most of the climate control is in the front of the vehicle. Okay, they do use LIN bus to communicate to this. Okay, the heater element both heats the coolant for the high voltage battery for active heating, which is essentially the interior of the vehicle. It is also controlled by the battery regulation, so not just the climate control unit, and it uses the LIN bus communication, so it knows where to do it, what to do, what purpose and what heating it needs to do. This is also your high voltage heater. This is the main cabin heater. It's regulated in 3 different stages. Air conditioning control module controls this one specifically. And now what we're going to get into, because these are the components on the ID4. So essentially every single ID vehicle that you will see coming out will have the exact same components. In theory, the parts should be interchangeable. It makes it a lot easier to acquire the parts at a dealer because they essentially should be all the same. So we can talk about Volkswagen Audi battery technology. Okay, nice little cutaway here of the battery units on, these are on the new Volkswagen and also on the new Audis. Okay, very similar, not exact, but very similar. If you take a look at it, you'll have the control unit, which on every single battery is built into the battery. You'll have the high voltage connection for the front and rear of the battery pack, because that's where it's going to connect to the power converter and the power electronics. You have a housing cover that's split. Okay. The battery frame itself is going to hold the actual battery modules. And then there will be a second set of battery modules at the very top. That's a smaller set. But on the very bottom and the underbelly guard, you will have cooling for this battery. Okay. It's also going to be coolant controlled. We'll get into a little bit more on that one. So Volkswagen is committed to building 6 new electric vehicle battery plants to help with their commitment to go all electric. They plan to have 6 plants built and all identical. The first one, which I believe is already has been built, and the second one is already built. The first one was at Salzgitter, Germany, and apologize if you guys are German out there and I'm saying it wrong. And then the second one is in Skellefteå, Sweden, and the third is in Valencia, Spain. Okay, right now those are the only 3 that are opened. They plan to have 3 more outside of Europe. Originally, they had planned to open one in China. With everything that's going on right now, not sure exactly what's going to happen to that. But they recently announced this past month, last month on March 13th, their first battery manufacturing plant outside of Europe is going to be in St. Thomas, which is just outside of Ontario, Canada. So the battery itself, this is the actual, what we call the chassis of the battery. Okay, you'll have internal reinforcements. It's a full aluminum chassis. This will house the battery modules themselves. This whole chassis is located underneath the vehicle. Reinforcements are put inside to provide the battery modules with the best possible protection in case of any type of accident or emergency. So in case of an accident, it should keep the modules in place, both longitudinal and lateral directions. It's essentially just like gussets on a roll cage. Okay. This one right here, essentially, this is the 62 kilowatt battery. You have 9 battery modules. So the first one we're going to be talking about is a Volkswagen battery. Okay. This is the ID4 and ID platform batteries. So 9 modules all installed there. The second one is the 12 battery, which is going to be the 82 kilowatt batteries that they have. Okay. So the 9 battery modules, those are going to be for like the base model ID chassis, the ones that have a lower range. The 12 battery modules are going to be in the all-wheel drive platforms, and the larger and more, as they say, luxurious trim packages available because of the equipment that is on the vehicle. So you got battery control modules installed. You will have, each one is its own, is a battery module, which is the lithium battery. You have a high voltage battery control module, which is actually controlling and monitoring the voltage and current in here. You have at the very bottom there, you'll see the high voltage battery control module, positive terminal, and then the battery regulation control module, which essentially does what the battery regulation module does on all of our cars now. Okay. I know there are people out there that have worked on the 48 volt battery, and they've seen that this battery regulation control module does exactly the same thing. It's just on a larger scale and higher voltage. 62 watt, 82 watt batteries components are almost exactly the same, very similar. And this can be taken apart for individual service. This is the upper part of the battery housing. As you can tell, this is a little cutaway. The heat sink is installed underneath the high voltage battery, and there's 2 coolant connections that go to it. So it is coolant cooled, and that heat sink will have the coolant running through it. The thermal management, obviously, like I said, is coolant based. Aluminum heat sink located outside the battery housing prevents contact between coolant and the high voltage components inside the battery housing. As we know, coolant can be corrosive and it can go through it. We have seen some issues with this, but they are working on repairing it and getting it in better ways. ID4, I think only a couple cars had coolant issues, but these newer ones, nothing has been seen. High voltage battery, like I said, located in the center of the vehicle. This right here is going to be on the Audi. Okay. So if you look at the Audis, this is specifically for the E-Tron. Okay. And this is not the E-Tron that you're thinking of. This is the actual SUV. This is a 36 battery module. It's installed in 2 levels. Battery housing connected to the body. High voltage control modules installed on it. And it's all going to, and the actual battery regulation control module is outside the vehicle on this one and is located by the A pillar, not internal like the predecessors. Okay. So if you look at the batteries, essentially it looks almost identical to the Volkswagen batteries. It's still coolant controlled for cooling. And like I said, the chassis itself is built very similar. So please take a note on this. The high voltage battery control module, which is installed on top of the battery, the power contacts are open if the following conditions are met. Okay, if the ignition switch is switched off, a crash signal is sent from the airbag control module. A crash signal is sent from the airbag control module to the high voltage interrupter. So that's like the fuse for it. Okay, or the maintenance connector is open, or the fuse for the power supply terminal 30C of the power contact is disconnected or faulty. So any of those conditions there should open the power contacts and deem this high voltage battery down. Okay. Just because ignition's off does not mean your high voltage is off. And I know Chris was asking about the fireman's loop on there. You can de-energize with the fireman's loop, which I'm getting to next. Fireman's loop right here, maintenance connector. They're located in almost identically the same exact spots. They do this for a specific reason, so they don't have to find it for every single car. The maintenance connector, it's in the front left air plenum. It has both the electrical and 12-volt control. Fireman loop disconnected, and then also the fuse, okay, which supplies the power for the control current for the power contacts. That's located in the fuse carrier in the luggage compartment. So you have it on the left rear luggage compartment, and you also have this connector on the left front. Okay. Make sure you look at this for safety precautions, but essentially that's what, you know, you'll see this on pretty much every single electric car out there. This is the statement in theory, as Chris was asking, can you de-energize it by pulling this? Yes, you can. It should de-energize the system. However, Volkswagens and the way their German engineering goes, they don't like it if you just pull it. It usually creates other faults. It takes a lot longer to get the car back to running condition on this, and to get it back up and running without all these extra faults. If you follow procedure, which you would have to use with Otis, the factory software, it should de-energize it correctly and get those capacitors down. And also when that happens, when you re-energize it, you won't have 1,000,001 faults as if you were just to disconnect this connector. So quickly on the E-Tron history and introduction. E-Tron here, I don't know if you guys even remember when this car first came out in Iron Man. This car was the first electric car that they tried to bring out, which was in the R8. They brought this as just a concept car. Okay. The E-Tron moniker, most people have heard this, has been around for a while. This came out in 2013 for the actual Audi A3 E-Tron, which is technically not even a electric car. It was actually a hybrid. Utilized the same 1.4 liter gas engine and electric motor as the Jetta hybrid. The A3 E-Trons, I'm sure you guys have seen it around. They had issues just like the Jetta hybrids. But in 2011, 2012, they actually had an all-electric E-Tron A3 that they were testing with their employees. So Audi employees had these and they were driving on the road. So I'm sure some of you may have seen an actual electric E-Tron, but this is where people were, you know, getting confused because the E-Tron was not fully electric. Okay. 2017, Audi started using plug-in hybrids with the A3, and you know, using it for the rest of their vehicles. In 2017, they were still using the moniker E-Tron with the A3s. Wasn't until 2019 that they were released their first actual full electric vehicle, which was the 2019 Audi E-Tron. Okay, the 2019 Audi E-Tron was an actual SUV based off the Q5. Okay, this is what they've used. Okay, the hybrid, plug-in hybrid electric vehicle. A lot of these monikers were the E-Trons. So they used that to get into the full electric market. 2019, this is the E-Tron that came out. This is actually a revised version of it. This was the first all-electric vehicle that they brought out as an Audi. This is the current E-Tron lineup from Audi. Okay, as of right now, they have been talking about releasing something similar to like an A8 or bigger. Obviously, I don't know if you have seen an E-Tron GT in person. It's similar to like an Audi A7. Okay, so we'll get through, kind of look at some of these real quick. This is the Audi E-Tron GT and the RS GT. They definitely love their designations. So all their E-Tron designations for all new vehicles now are all electric. E-Tron GT makes 469 horsepower, 464 foot-pounds of torque, and 522 horsepower or 472 foot-pounds of torque under their boost mode, while the RS E-Tron GT makes 590 horsepower, 612 foot-pounds of torque, or 637 horsepower, 612 foot-pounds of torque stays the same, and under boost mode. E-Tron GT gets about 236 miles on a full charge. RS E-Tron GT gets 232 miles. There have been cars out there, even during testing, that will reach 285 to about 290s on a full charge. Numbers are a lot smaller because I'm sure you guys have worked on Volkswagen and Audis and know what happened with the Dieselgate concerns. So they got their hand slapped pretty hard. Their mileage was, they kept it low on the Moroni and their mileage was a lot higher. Obviously on here, there's no emissions to go through. So they've kept the numbers low, and most of these cars are getting anywhere from 250 to almost 300 miles on a full charge. The only difference is on these RS E-Tron and the E-Tron GT, they both run a 2-speed transmission, which is, I believe, a first in the electric car market. Q8, SQ8, Q8 and Q8 Sportback. SQ8 is a bi-turbo engine, which we're not talking about here, but these two here look very similar to the SQ8 and a regular Q8 out there. These are all electric. They have the same exact motor for both vehicles. Okay, they both produce 355 horsepower, 414 foot-pounds of torque, or 402 horsepower, 490 foot-pounds of torque under boost mode. The e-tron, the Q8 e-tron gets 285 miles versus the Sportback that gets 300 miles. Obviously, it's because of the size difference. The Sportback is slightly smaller. Don't do that on the very bottom there, driving through water. Obviously, these electric racks, I'm sure you guys have gotten in your shop for all these Audis. You go through water and those things go out. But the biggest thing is that Audi says that we can take these things off-road, and there have been a couple guys that have actually taken these things off-road without an issue. Audi also makes a Q4 Sportback, little baby version similar to, this is actually based off of the ID4. So if you look at the Q4 and the Q4 Sportback, it's identical as far as the chassis and the platform goes to the ID4. Same batteries. It's based off that MEB platform. Okay. Obviously, it's an Audi. It's got a little more high-end touches on the interior. Last portion on here that we're going to be talking about, Audi e-tron drivetrain and gearbox technology. So these right here are going to be a similar drivetrain and battery across the board for all the Audi e-trons. They're not going to be identical, obviously, because if you notice, the vehicles are a lot different in size. So 2019, that e-tron, when it first came out, was the first full-size SUV. Essentially, it was a Q5 put on top of an electric motor chassis. Okay. Quattro, twin engine. Basically, what they wanted to do was make an SUV full electric and see how far that would get them. Little breakdown of the e-tron engine. All the engines are very similar. So they're going to have coolant connections going to it. It is coolant cooled going to the engine. The coolant actually wraps around the stator. Okay. The stator itself has a jacket that stays within the coolant. So the brushes and the housing on there and the rotor do not get coolant. However, on these newer e-trons, we have been seeing issues with coolant ingress. Okay, little cutaway here of the two different engines. One's a front axle and one's a rear axle. The motors are slightly different from front to rear. On the front axle, power electronics, electric drive motor are connected in series within the coolant circuit. The coolant flows through the power electronics, then through the water lance on the front axle to enable the internal rotor cooling. The coolant subsequently cools this through the stator cooling jacket, and then it goes back into the circuit. So it's the same coolant that runs throughout the entire cooling circuit. The rear axle, the coolant flow also flows through the power electronics first on the rear axle. So look at sensors in that power electronics to deem how this thing is getting cooled. The only difference is that stream continues around the stator cooling jacket, and after that, the coolant flows through the water lamps on into the rotor and back into the circuit. So different variations of the E-Tron GT engines here. There were 3 different variations because the rear engines were different versus the rear motors were different than the front motors. So the rear motors were the ones that had more power or torque depending on which version of the E-Tron you had, GT you had, and then the front axle motor was exactly the same. So difference between the front and rear motors, you can see this is the front motor. You still have your housing, your stator, your rotor going through the cooling jacket itself, and then the drive motor rotor position sensor. Okay, take a look at that. And then I'm bringing up the rear axle here. The rear axle, the motor looks similar. However, the difference you're going to see in the next picture is the drive motor itself is the stator itself. Okay, you can see a much larger one depending on which variation you have. So as you can see on the left, E-Tron GT, on the right, RS E-Tron GT. That outer housing is essentially the same. In theory, you know, I'm sure there will probably be someone that swaps it over, or you can find one or the other. You can swap that over. Electric drive cooling system. Coolant flows through electric drive motors on the front and rear axles. It's integrated into the cooling circuit for the electric powertrain. Coolant flows in its first direct to the power electronics, so it can dissipate the high levels of heat at the power module. Then coolant flows through the stator cooling jacket on the rear axle. The coolant additionally routed through the 2-speed transmission unit. Okay, only on the Audi E-Tron GT, you have to run G12 Evo coolant, a little bit different than our normal coolant. Last couple things to talk about here, just the transmission here. Every single one of these electric vehicles here will run either an OMA or OMB single speed transmission. Okay, depending on the location is going to be which transmission you're running. So as you can see, on the left is an OMA single speed, on the right is an OMB single speed transmission. So it will depend on which electric motor you're having. So OMB is usually on the rear electric motors versus the OMA is on the front electric motors. Little cutout here of the front single speed transmission on, this is the OMA. Single speed OMA, 2-stage reduction ratio, modern lightweight planetary gear differential. It's equipped additionally with an electromechanical parking lock. Torque conversion takes place in 2 stages. First reduction is achieved via a single planetary gear set from the sun gear to the planetary gear and the planet carrier. Second stage reduction is a spur gear that drives and transmits the torque from the planet carrier to the differential. OMA transmission has its own oil system. It's a bathe and splash style system. Uses the displacement effect of the spur gear stage. Oil guide plate and the oiling system uses various channels and contours to make sure that all components are lubricated correctly and adequately. Heat is dissipated by convection to the vehicle airstream and a water-cooled bearing plate on the electric drive motor. The OMA transmission is a complete unit. However, it's not a self-contained housing. So only when it's connected to the electric drive motor does it form a closed unit with its own oil system. So you could not pre-fill this transmission if it was not connected to the electric motor. Same thing's going to go with the single speed OMB transmission for the rear axle. Runs a single 2-stage reduction ratio and a coaxial design and lightweight planetary gear differential. Differential is is largely identical to the differential of the OMA transmission. Same style, bath and splash style system for lubrication. Thanks to the coaxial design, no special parts are required for oil distribution, like the oil guide plate on the OMA transmission. And obviously you can see this transmission is a lot smaller. So it's not that funky style shape. Same way, heat is dissipated by convection, vehicle's airstream via water-cooled bearing plate on the electric drive motor. OMB transmission is a complete unit. Same thing, it's not a self-contained housing. It has to be connected to the electric drive motor to be completely closed out so you can put the oil in, okay? Last but not least, this is the 2-speed transmission on the E-Tron GT. It's fitted with the 2-speed transmission on the rear axle only as a standard equipment. The transmission unit is fitted parallel to the axle, has 2 continuous speed reduction stages and 1 planetary gear set. The transmission unit has a factory designation EQ550-2P. Active differential lock is available as an optional equipment for the E-Tron GT and also the RS E-Tron. Is equipped with the differential lock standard. Okay, so components are interchangeable. The 2-speed transmission, which has a first gear and second gear, right? Because it's 2-speed. The first gear is used for launches and launching the vehicle and getting it up to speed. The second top gear is used for optimal efficiency. So once the car is moving, it switches to the second gear for better mileage and as far as going through the battery itself. Okay. Volkswagen Audi's mission as far as this things go for the future. So obviously people are getting more and more interested in the electric car market, and with Volkswagen ID technology and Audi E-Tron, the plan is to have at least 30 new electric models by 2025. Okay, so this was introduced in 2021 or 2022 when they said that. That means the ID4, the Buzz, pretty much every single Audi E-Tron that's available now is part of that 30 new. So expect a lot new models to come out by then. They want to introduce only all electric models from 2026 on, and phase out any fossil fuel vehicles in the lineup by 2029. Obviously, it's a bold statement. California has it where they want all electric vehicles by 2030. We'll see if, I don't know where everybody is, but California is not set up for that kind of power grid yet. I don't even know if it will be set up by 2030, but it's really going to depend on that. And obviously, you're going to be seeing a lot more of these Volkswagen Audis on the road. That concludes. This is the car. This is what we have. Essentially, this is the conclusion of our webinar here.